back again. In today's class, we are going to look at most likely questions you are going to see on qualitative analysis. Now, I'm going to introduce my mommy to guide you through most possible questions you are going to see in respect of these NECO exams. With no further ado, let's get right into the video.
Good day, my viewers. This time I have to take you through the question number 2, which is a tight qualitative analysis, where you have some samples given to you. Here we have 2 samples, sample C and D. So the question goes like this. You are provided with 2 inorganic samples, labeled C and D. Carry out the following exercises on them. Identify any gas or gases involved. State the conclusion drawn from the result of each test. Then question 2A. Put half of C in a test tube and add about 10 cm cube of distilled water and test the resulting solution with litmus paper. Divide the solution into 4 portions. Then 2BI. To the first portion, add sodium hydroxide in drops, then in excess. Then 2BII. To the second portion, add aqueous ammonia in drops, then in excess. Then 2BIII. To the third portion, add few drops of K2Cr2O4 solution. Or to the third portion, add few drops of potassium iodide. Or to the third portion, add dilute HCl aqueous and heat, then allow to cool. You might wonder why the or there. This is supposed to be a confirmatory test for the cation we are expecting. Another confirmatory test goes like this. You can use the potassium iodide as a confirmatory test, and you can as well use dilute HCl as a confirmatory test. So I will carry out this, I will carry out this, I will carry out this based on the third portion. So any of these 3, one is likely to be asked. Then after that, we now go to 2BIV. To the fourth portion, heat strongly. That is the fourth portion of solution C. You might be asked to heat it strongly. Or they will now refer you back to the other half we never used, which is, and I say, or put the remaining half of C in a boiling tube and heat it strongly. So it's either this or this. So don't get confused when you're seeing the or and the word or. Thank you. Remember, we have 2 samples. So for the second sample, which is sample D, that's supposed to be 2C. Put all of D in a test tube and add about 10 cm cube of distilled water and test the resulting solution with litmus paper. In case they didn't ask you to test with litmus paper, don't bother commenting. But if you are asked, you can now write when I go to the solution side. Then 2CII. To 2 cm cube of this solution, add barium chloride aqueous, followed by dilute HCl and heat. Then the last one, 2CIII. To another 2 cm cube of this solution, add few drops of acidified KMnO4 solution. Thank you. Let's go to the solution aspects.
These are the reagents required to carry out this task. You can see it. These are distilled water. This is sample C and sample D. This is our potassium chromate, and these are potassium permanganate. These are potassium iodide. This is ammonia. This is HCl. This is sodium hydroxide, and this is barium chloride. So let's proceed with the experiment.
That's sample C. That's my test tube. So I'll take half of C and put it in the test tube as instructed. You cover it. That's distilled water. About 10 cm cube. You have to estimate 10 cm cube. This is 10 cm cube. You have to check it. If you have a glass rod, you can make use of glass rod. Make sure it's clean. You stir it. Make sure it dissolves because it's a soluble salt. It has to dissolve. So now that you have seen what has happened, the sample C dissolved to give a colorless solution, which means that sample C is a soluble salt. It dissolved to give a colorless solution. So you have to report exactly what you have done according to the number. They might change the number, but still follow the numbers. So this is 2A C plus water. We now say that C dissolved to give a colorless solution. That's it. So what do you have to infer? C is a soluble salt. Still on that number, you say you should test the solution with litmus paper. So you're not going to draw your line. You now say plus litmus. Make sure you follow that line of the litmus. So here, I have some litmus paper here. We have to test with blue litmus paper. So we test with blue litmus paper. You might not see a very sharp color change because I tried to get some blue litmus paper from the chemical store. It happens to be scarce for now. I'll still try it. It will take some time before it will now change to, I had to now improvise this. I used the red litmus paper, pour some base on it to be able to convert it to blue litmus paper. So you might not see exactly red, but when on the very day of the exam, when you use your correct blue litmus paper, it will turn it from, you can see that some part is becoming reddish. It's not properly red, but it will change it from blue to what? Red, indicating that the solution C is acidic. You will not say it's acid, but what? Acidic. So you can see that some part of it is changing, but it's taking quite some time. So pardon me for that. So for litmus paper, what do you see? Solution C. Solution C change blue litmus to red. That's what we want to see. So we comment solution C or C aqueous. Make sure you put aqueous. C aqueous is acidic. Not acid, but what? Acidic. You can underline. We are done with that number. So you go to the next number. And the next number says that's 2B. They say you should take first portion, divide solution C into 4 portions. So we are going to work with portions. I have to take the first portion. Here I have my test tube. So I will not just start dividing solution C They just have to tell me that I should know that I should use it up to 4 times. So I should be careful the quantity I'm using. So I make sure that it can serve me for the other test. So this is the first portion right now. I'm asked to add the sodium hydroxide in drops, then in what? Excess. So I'll now add sodium hydroxide in drops. You might not necessarily start using a dropper. You can estimate, but make sure you don't over add. They say you should add it in what? Drops. So you do that. I've added in drops. You can see it has given us white PPT. Please don't say gelatinous. If you say gelatinous, no score. There's a difference between white PPT and white gelatinous PPT. So what I have here is white PPT, which is white precipitate. So you now write and comment. This one you can say C applause for first portion, and write first portion plus sodium hydroxide solution in drops. Comment before you go in excess. You now say white PPT is formed. So what you have to infer, there are two cations that can give you white PPT. You now say PB 2 plus or CA 2 plus is present. These are the two cations that can give you white PPT. Then we are not done with the number. We are now going to add in excess. So you add in excess. Excess where? Excess in what? The white PPT that you have already formed. So it asks you now to add in excess. So when you now add in excess, you notice that the white PPT will do what? Dissolve. It has disappeared. It's no longer there. It dissolves, okay? So you now say, don't say soluble. If you say soluble, no score. What you say? You now say that white PPT did not, white PPT dissolved. White PPT dissolved. That's what you're going to write. Because it dissolved, it's not calcium ion, but what? That 2 what? Ion. But if it did not dissolve, then it is what? Calcium. But it dissolved. You can see that it dissolved. So it is lead 2 what? Ion. And as the lead 2 ion is what? Present. Don't say confirm. That is not a confirmatory test. You can now underline. That number is here, over. We are now going to the second portion. So we are done with this. So let us go to the second portion. So I take another clean test tube. Back to my C solution. I have to take another portion. Remember, you are advised to use it 4 times. So don't just take little at a time. So that's my second portion. This time I'm asked to use aqueous ammonia. And that's your aqueous ammonia. You cover every reagent after use. So you take your aqueous ammonia, you put it in what? In drops. Just in drops. You see? Exactly what happened with sodium hydroxide has happened again with aqueous ammonia. So you comment, you now say, that's a 2B. Please, numbering is very important. Make sure you put your numbers correctly. Second portion. Second portion plus ammonia solution with aqueous in drops. You comment what you observe. White PPT is formed or formed. YPPT formed. Because YPPT formed, now this time around, because you use aqueous ammonia, we have not going to bring down calcium. Calcium has nothing to do with aqueous ammonia. If you bring down calcium ion, it's a wrong cation, -1. So what will be here is what? Lead 2 what? Ion is present. Remember, don't bring down calcium ion. Calcium ion or calcium salt has nothing to do with aqueous ammonia. Then you now put in excess. Excess of what? Use your aqueous ammonia. So this time I have to put in excess. I can I can even fill it up if I want to. It will never dissolve. In fact, the more I add, the more is formed. So remember with the case of sodium hydroxide, I didn't get to this extent and everything dissolved. You can see that the same measure, it did not dissolve. That means it is lead 2 ion is present. It can never dissolve with aqueous ammonia. You now say in excess. In excess, like I said before, don't write insoluble. Tell us what you observe. White PPT did not dissolve. Did not dissolve. That means lead 2 ion is present. It is not a confirmatory test. So that's what you have to write. I'm done with this number. So we are going to go to the next test, which is using the third portion, which I call the confirmatory test. So that remaining portion there, I have to minimize it, I have to control it so that I'll be able to use it 3 times for the third portion. Good. Let's go to the third portion. That's still the sample C solution. I'm taking the third portion. Remember, I have to use it 3 times. So I'm taking the third portion. So that's the third portion. In the third portion, I'm asked to add a solution of K2CrO4, and that's it here. So I'll add it, few drops. You can see what I'm doing. What have you seen? PPT. Look at it very well. You can see the particles there. That's yellow PPT is what? Form. That's a confirmatory test for lead 2 what? Ion. If you use this reagent. So I have other reagent I will use. So I have to report. That's the third portion this time, which is 2BiII. C plus, or I say third portion, plus K2CrO4 solution. What did I observe? Yellow PPT formed. So that means lead 2 ion is confirmed, not present. Lead 2 ion is confirmed. So if they didn't ask the other one, that's where you stop. But since I say oh, let's try other one. So we are still with third portion. They can never ask you 3 confirmatory tests in one test. It's either they ask with this K2CR2O4, or they ask with potassium iodide. That means I'm going back to the same third portion. It's not fourth portion, but what? Third portion. So that's my third portion. I have to use potassium iodide. I have potassium iodide here. That's my potassium iodide. Make sure you look at what you're adding before you add. So I want to add potassium iodide to the third portion of C. You see, this one is described as bright yellow PPT, quite different from the other one. Look at the other one. It's not as bright as this. This one is with the K2Cl04 solution, but this one is potassium what? Iodide. Both of them are confirmatory tests from N2 ion. So you can see, so what do you write? I will not say the same number. I will say third portion plus potassium iodide solution, a bright yellow precipitate, which is allowed to be written as PPT, formed or is formed. The same lead 2 ion is confirmed. Then the last confirmatory test, whichever one you want to ask, to be on the safe side. This time I'm using this as it is. Though it's much, I can still reduce it. It's better use little quantity than using a large quantity so that you'll be able to get results. So don't use much. So I can use this quantity. I'm okay with this quantity. So what am I trying to do? They say I should add the dilute ACL. Of course, when you do that, you observe a white PPT. Watch. This dilute ACL. So when you add it, you observe white PPT. White PPT is formed, but you are asked to heat. So when we go to heating, we observe something there. But you can comment before you go to the heating. You can say, I'm still putting all because I'm still dealing with the third portion. So third portion plus dilute HCl, I observe white PPT. Let me rest my point here because I am doing confirmatory test for what? For lead. But if I say Pb2 plus is present, I'm not wrong because it's a test for confirmatory test for what? Lead 2, or I might not write anything. At the end, I will not say lead 2 ion is confirmed. Let's go for the heating. You use your test tube holder. You hold it. That's the test tube holder. You now start heating. You heat it. It's a confirmatory test. The white PPT will disappear. And when you allow it to cool, it will reappear. What am I trying to say? Since we are suspecting lead here, which is lead 2 ion, the ACL added, a chemical reaction must have taken place. So this white PPT is no other PPT but lead 2 chloride. And lead 2 chloride dissolves in hot water. It's an insoluble lead salt, but in hot water it dissolves, and in cold water it has to remain inward soluble. So that is the test we are doing here. So when you heat up the solution or the suspension, you notice that the white PPT will dissolve. It will disappear. You will not see it again because lead 2 chloride is meant to be soluble in hot water. Just like I told you, it has all disappeared. So the white PPT has disappeared. So when you allow it to cool, it will reappear. That is a confirmatory test for lead 2 watts ion. On heating, white PPT form white PPT appeared on heating and reappeared on cooling. What do you say? PB2 plus is confirmed. That means you have to indicate here plus heat, then cool, so that it will correspond to what we have just done. They say then heat and allow to cool, plus heat and plus what? Cool. Then the fourth portion, we have to heat strongly, and that's the fourth portion of C. Just have it in mind that I am carrying out all the necessary tests. Or some of them can be asked just to be on the safe side. Try to observe everything. So whichever one that is asked, you've seen it, you saw it, you observe it, you can now report very well. You can see that is condensing at the upper part of the test tube. Of course, that one is not necessary because you added water to sample C. So it's not a discovery. Observe the color of the test tube. It's turning reddish brown. From the body of the test tube, and the gas is reddish brown in color with a pungent smell. Just like I earlier said, I don't have the correct litmus paper. It will change that blue litmus paper to red, meaning that the gas is acidic. And if it is confirmed with starch iodide paper, it will turn it blue-black. That means NO2 gas is present. Reddish brown, you can see. And the residue form yellow when hot, and when you allow it to cool, it will turn reddish brown or brown. Can you observe it? Okay, can we do the last one, which is hitting the other half of the word? C. Maybe we'll observe it better. Fourth portion plus heat. Yellow residue formed when hot and turned brown when cool. That's about the residue. Then a reddish brown. For this one, we say EDO is present. That's how the two oxides behave, which is the residue from the salt the salt solution that was heated up. The reddish brown gas evolved a reddish brown gas, sorry, with a pungent smell. The color goes with the odor for 1 mark with a pungent smell involved. That's 1 mark for the color and the odor. Then you have to test the litmus paper. The gas changed, damped, blue, litmus paper, red. You say the gas is acidic. Then you have to confirm every gas for you to score for the gas. Must. So you have to confirm the gas. How do you confirm NO2 gas? You say the gas turned, damped, starch, iodide paper, blue, black. Sorry, I don't have the paper here, but that is the confirmatory test. You can now say, because you have confirmed the gas, you now say the gas is NO2. From where? From NO3 minus. Is the gas that will portray the anion. So it is the gas that tells you that the anion is NO3 minus. So every gas, there are 4 tests you must carry out with the gas. You have to tell us the color and the odor for 1 mark. You have to test with litmus paper to whether it is a neutral gas or acidic gas or alkaline gas. Then the last one, you have to confirm the gas. So this is the confirmatory test for the gas. So with that, you can now say the gas is NO2, which is the nitrogen 4 oxide. From where? From triosonitrate 5 ion, which is NO3 minus. So that's for the anion test. Remember, we are done with the cation, which is lead ion. This time is the test for the what? The anion, which is the NO3 minus. Or they might ask you to heat the other half of C. So this is the remaining part of the C. So I have to empty it into a boiling tube and heat it strongly. Either they ask you to use the 4th portion like we just finished. That one wasted a lot of time, and probably you can see the other one I just finished. You can see that it's getting cold and it is a reddish brown. But while it was hot, it was yellow. I mean the residue that's formed from the salt solution after being heated. So this time I'm now heating the remaining half of C. They might ask you or they might not ask you. But to be on the safe side, you have to do all the tests. And there's something I also omitted. When I added water to sample C, I noticed that the test tube, I felt a cold sensation, meaning that the dissolution of the sample C is endothermic. It was endothermic because heat was absorbed from the world surrounding. So if you do that and you observe that, please do well to say that the reaction vessel feels cold, meaning that the dissolution of C is endothermic process. Now here, you can observe the crackling sound. It's very important. I'm hitting it directly and I'm observing that crackling sound. So from there it will melt. You can observe the sound. That's the gas. That is NO2 gas. That's the color. You perceive it, it has a pungent smell. How do you perceive it? It has a pungent smell. You can see it. That's just what we want you to see. You see that the anion there is NO3 minus. That's the only anion that can give rise to a reddish brown gas known as nitrogen 4 oxide gas. Can you see the reddish brown? Very pronounced. The entire test tube has turned what? Reddish brown. The gas is evolving plus heat. C. Decomposed. Reduced a crackling sound. I told you to observe the sound. Crackling sound. A reddish brown gas with a pungent smell evolved. The gas change band blue litmus paper. Red, follow here. The gas, don't forget, is acidic. The gas turned damp starch iodide paper blue black. That's the confirmatory test. Follow that line. The gas is NO2 from NO3 minus. Also, the residue is yellow when hot and brown or reddish brown or brown when cold. That is, the residue is PbO. You say the two oxides is present. Thank you. You can see that the residue is yellow when it is hot because it's still hot. So if you allow it to cool, it will turn back to reddish brown. That's it. Very important. You have seen it. That's the behavior of the two oxide. When it is hot, it is yellow. When it cools, it will be reddish brown. Take note of that. So sample D. That's the second sample. So I'm gonna now use all of them. That's it. So sample D plus water, about 10 cm cube. It's okay. Allow it to dissolve. You can use a stirrer to be very careful not to dissolve to give a colorless solution. We are asked to, okay, let's report first on what we have observed. D plus water. D dissolved to give a colorless solution. Very important. D is a soluble salt. We are not done with D. You say you should test the solution with litmus paper. And now say D aqueous. Because you don't put aqueous, that means we are testing with a solid D. D aqueous plus litmus. So we are going to test with litmus paper. I think this is a original red litmus paper. So let's see it. It will turn the red to what? Blue. It will turn it to blue. You can see that it's turning it to what? Blue. If you leave it after some time, you see the real blue. So you don't need to waste time. It has touched the paper, the litmus has touched the solution, so you leave it for a while. The blue color will appear. That's it. It turned the red to what? Blue. The blue is faint, but it turned it to what? To blue. I'll keep it later. I will call your attention to it. Let's keep it somewhere. You can see it's blue. In case, so it turned it to blue. So this time, let's say red litmus turned blue, meaning that solution D turned red litmus to what? Blue. So what is solution D? Solution D is alkaline. Is alkaline. Or alkaline solution. Is an alkaline solution. Is an alkaline solution. Or is alkaline. Anyhow, you underline. We are done with that number. So once you are done with a number, you underline. But always leave some line, some space, in case there is something you have forgotten and you remember. You can go back and fix it in. So we are going to now start working with the portions as instructed. Now we're working with the first portion, the 2 cm cube of the solution. So I'm taking about just 2 cm cube, not much. Remember I said don't work with too much portion, just take little at a time. So that is that's a D solution. This time you are asked to add barium chloride. So that's barium chloride. You now add barium chloride. They did not specify, just add. You have to observe a white PPT. That's a white PPT. And anytime you make use of barium chloride and you observe white PPT, you have to suspect 3 or 4 anions. So I'll just say D solution, meaning of saying 2 cm cube. It's not necessary. D solution plus barium chloride aqueous. We observe white PPT. White PPT is what? Formed. Tell them that it is formed. Now, because of this white PPT, we are going to suspect XO3 2 minus XO4 2 minus, comma, CO3 2 minus, or at the end you put or sulfide ion. So any of these four could give us a white PPT with barium chloride. Then we are now asked to add, still on that same number, add dilute HCl. When you add dilute HCl, nothing will happen until you go and do the heating. Even like that, most times it's supposed to dissolve, but it doesn't dissolve. But not, don't say it did not dissolve, because in your marking scheme they will tell you that it dissolved and they will start reporting. So if you say it did not dissolve, you are on your own. So let's do it. If it dissolves for us, good enough. If it doesn't, no problem. You comment as usual. So where is the ACL? That's ACL. You now add the ACL, which is supposed to dissolve. It did not. Probably they want us to go and heat it so that it will dissolve. So we're going back to do the heating. But if it doesn't, you go ahead and report. That is our adulterated salt these days. I don't know. Heating. I'm heating. The heating is supposed to make the YPPT to dissolve. Even the ACL is supposed to dissolve it. I believe that the heating will now help to increase the rate of the reaction, because increase in temperature increases the rate of reaction. Okay, I will not waste much of your time. Let me go ahead and give you the reports. White PPT dissolved to give a colorless solution on heating, of course. A colorless gas with a pungent smell. You can even tell them that you know what you're doing. A pungent smell like that of a burning matches. A burning matches. Okay? Evolved. Okay? You have 4 tests to carry out on your own. They won't tell you what to do. They say identify any gas or gases involved. That's what you are doing here. The gas turned, damped, blue, litmus, red. Stop and comment. The gas is acidic. Good. That's about his test with litmus. Final test, which is confirmatory test. The gas change acidified purple KMNO4 solution to colorless. This is a confirmatory test for this gas. I'm about to tell you what it is. Good. Or you can complete it without a deposit of yellow sulfur. Why must we put this? If the gas is nitrogen sulfide gas, it will behave the same way, but it will deposit yellow sulfur. But for this very gas I'm about to state, it will dechlorize the KMnO4 without depositing yellow sulfur. So based on that, you have confirmed the gas. You say the gas is XO2 from XO3 to minus, meaning that it's not XO4 to minus, and it's not CO3 to minus, and it's not sulfide ion. The anion present is XO3 to minus. That is it. You underline. Then the last is testing with KMnO4 itself. Another 2 CMQ portion of D. That's supposed to be the last number. And that number is remember this. Remember the 2CII. So this is supposed to be now 2CII. Okay. So that's the KMnO4. You can see it's purple in color. You are asked to add few drops of this KMnO4 to the second portion of your words. D. You now add. You can see you are adding. The color is being decolorized. Can you see? You are adding. The color is being what? Decolorized. The color is disappearing. What does that tell you? That there is reducing, this sample D is reducing agent. Let me try it again. You can see that as the more you add, the more the purple color is disappearing. That's interesting. I hope you can see it. Good. Aqueous plus acidified KMnO4 solution. That is it. You say the purple color of acidified KMnO4 changed to colorless. That's it. Meaning that D aqueous is a reducing agent. Or you say reducing agent is present. That is it. Thank you so much for going along with me. That is all that they might ask in this number 2 qualitative analysis question. See you some other time. Bye.
Thank you so much for staying and sticking to the end of this class. I hope this video was able to help someone out there. Please don't forget to subscribe to this channel and turn on notifications to get notified each time I post videos. And lastly, do not forget to share so that other students are preparing for this same forthcoming exam can see it and learn from there. I'll see you next time in the next one. Bye for now.